Mean, median, and mode. Mean, median, and mode. Come on everybody, so here we go. The 3 M's that you really need to know. The mean, median, and mode. So, mean, median, and mode. Everybody come on, so here we go. The 3 M's that you really need to know. Mean, median, and mode. The mean, the mean. Come on kids, really, it's not so bad. Grab your data numbers from the table and first you start to add. When you finally have them added up, then can you only divide? Because this is how you find the mean. Yes, the average number, that's right. Now that you found the average number, you see what I mean? Ha, ha, yeah, yeah. Come on everybody, just do it again, please. Add them up and then you divide by the total number in the table, that's right. Add them up and then you divide by the total number in the table, that's right. Mean, median, and mode. Come on everybody, so here we go. The 3 M's that you really need to know. The mean, median, and mode. So, mean, median, and mode. Everybody come on, so here we go. The 3 M's that you really need to know. Mean, median, and mode. The mode, the mode, the mode, the mode, the mode, mode, the mode, the mode, mode, mode. M-O-D-E. It's the number with the highest frequency. It's the number that you will most often see. Come on everybody, find the mode with me. The mode, the mode, the mode, the mode, the mode, mode, the mode, the mode, mode, mode. M-O-D-E. It's the number with the highest frequency. It's the number that you will most often see. Come on everybody, find the mode with me. Mean, median, and mode. Come on everybody, so here we go. The 3 M's that you really need to know. The mean, median, and mode. So, mean, median, and mode. Everybody come on, so here we go. The 3 M's that you really need to know. Mean, median, and mode. For the 3rd M, just think of a road. Median, the number in the middle for sure. Before you start driving for the median, take this one step before you begin. Order, please. It's the one thing requested by Mr. C. It's like a little mathematics guarantee. Make a thing so nice and so easy. Take a step from side to side. Only take one step at a time. You have a green light, now it's your time to shine. One from the left and one from the right. Take a step from side to side. Only take one step at a time. You have a green light, now it's your time to shine. One from the left and one from the right. Median, and mode. Come on everybody, so here we go. The 3 M's that you really need to know. The mean, median, and mode. So, mean, median, and mode. Everybody come on, so here we go. The 3 M's that you really need to know. Mean, median, and mode.
Can you forgive me for playing that? Can you? That's going to be stuck in your head for as long as you live. Okay, I hope you enjoyed that. All right. I'm not sure if I can beat that, but I'm going to give it a try here. All right. So I want to cover the measures of central tendency maybe in a little bit more seriousness than that. I don't know if I can beat that. All right, here we go. So measures of central tendency are kind of like the tent poles. Okay, going camping in tents is going to be kind of a theme here in this video. So just like in the tent, you know, the pole right down the middle. That's similar to a measure of central tendency. We like to know where the middle of things are. All right. So you know, when you guys took exams and came back to class afterwards, you always wanted to know what the mean was. You know, what's the average? What's the middle of the class like? How do I compare with the middle? All right, so we're always, that's always an interest of ours. In the next segment, we're going to learn about measures of variability, and we're going to kind of learn about how the tent is spread, okay? We'll come back and talk about measures of how wide the tent is, you know? Is it a narrow tent? Is it a wide tent? Is it a medium tent? Those are measures of variability. So measures of central tendency are about the poles holding up the middle of the tent, okay? So, as the video says, we've got 3, the mean, the median, and the mode, all right? The 3 M's, here we go, all right? So the mode, and sometimes is abbreviated as MO, because I guess the word mode is just a little bit too long to write sometimes. And so this one's really, really simple. It's just the most frequent occurring score or value, sometimes thought of as the most typical or common, all right? So it's whatever number pops up the most frequently. And if it's data that we haven't yet put into numerical form, like ethnicities, all right? Eventually, maybe we have to convert those into a nominal scale variable and give them numbers, but until we do so, the most typical or most common ethnicity for a group in the U.S. Might often be Caucasian, all right? So you can consider that the mode ethnicity in many, at least many parts of the country. So it can be thought of as the mode. So it's the only measure of central tendency that's going to be available when we are limited to something that's on a nominal scale of data. All right, so ethnicity, gender, anything that's on a nominal scale is we're going to be limited for these three measures of central tendency. The mode is the only one available that we can use. All right, will make no sense to calculate the median or the mean. So it can be used for all scales of measure. You can use the mode for ordinal, interval, and ratio scales. But if you have nominal, you're stuck with only the mode. That's your only choice. Okay, so I want to tell you about a fairly common mistake I see students make, and sometimes I worry that by pointing out the mistake, some of you might incorporate this mistake. So don't make this mistake. All right. Some people mistakenly think that the number of times the thing occurs is the mode. All right. So it's not the number of times that most frequent thing occurs that is the mode. It's the thing or the number that occurs most frequently. So consider this little pile of numbers here. Okay, we got 2, 3, 8, a bunch of 8s, a bunch of 10s, and then a 12. All right. So the number 10 appears 8 times. All right. So the mode is 10. It's not 8, okay? It's not the number of times it occurred, all right? So the mode is 10 occurring 8 times, okay? So don't make that mistake that I sometimes see people reporting that the mode is the number of times the most frequent occurring thing occurs, okay? Now sometimes there will be more than one mode, and sometimes there will be officially more than one mode, and sometimes there will be for all practical purposes, more than one mode. And we kind of covered this already when we introduced this bimodal distribution in another lecture. So if these two humps are exactly equally tall, then the value that's directly under the highest peaks are the two modes. Okay, it's bimodal. Each mode appears equally often. All right. So if they're exactly the same height, if they occur exactly the same number of times, then it's truly bimodal, all right? Now, a computer, remember the warning, a computer is SPSS and Excel and other stat programs are very, they're going to tell you without exception, I think, that, what the true mathematical mode is. So if one value occurs, 1,000 times, okay, let's say something occurs a lot of times, 1,000 times, is the most frequent occurring value in a big pile of data. But then there's another number that occurs 999 times, all right? Just one less, okay? Well, it's going to dutifully report, that the item that occurred 1,000 times is the one and only mode. But when you look more carefully at the data, you see, well, gee whiz, there's a second one that occurs just about as often, all right? So, all right, that's why we graph the data. That's why it's important to look at the trend, okay? Because now, let's imagine that this one's a little bit taller here. And so, yes, technically this one over here is the one and only mode. But when you look at the data, you unmistakably see a second hump over here. And so the computer would fail to tell you that, something that your eyeballs can so quickly see. All right, so you can have bimodal, trimodal, or multimodal modes, okay, in your data. All right, the median. The median sounds simple, but as you're going to see, it gets a little complicated sometimes, all right? So the median is the middlemost score in a distribution, all right? And we sometimes abbreviate it MD or MDN. There's no other symbol that you typically will see for this, all right? So the median, it's the middlemost score. I should have on here, insert in your notes, I should say the middlemost score in a sorted distribution, not sorted distribution, a sorted, okay? Once you first must sort the data from least to most, or if you're anti-establishment, you could do it from most to least, okay? But one way or another, you got to put them in a sequence, in an order, all right? then it's the middlemost. Okay, if you got just a random, if the numbers were randomly distributed, randomly ordered, okay, it's not just what happens to be the middlemost number. You must sort them first. Okay, sometimes I see students fail to do that all important, crucial step. The first thing you must do is sort the data, preferably from least to most. Okay? You can't use the median for nominal scale variable. It just makes no sense. But you can use it for ordinal, interval, and ratio data. Now, as we're going to see when we cover the next one, the mean, we'll typically most often want to use the mean for interval ratio scale variables. And so very often when we're reporting medians, it's often because we have ordinal data. So that's as far as you can go with these three measures with ordinal data. You could report the mode or the median, but it makes no sense to compute a mean for something that you've only rank ordered, okay? If you rank order 5 things, 5 favorite candy bars, 5 favorite sodas or whatever, okay? It would, so your ranks would be 1, 2, 3, 4, and 5, and no matter, if you do that for every participant, you give them 5 things to rank, they're all going to have ranked order, they might rank different things, but everyone's going to have 1, 2, 3, 4, and 5 in their list, and the mean is always going to be 1 plus 2 plus 3 plus 4 plus 5 divided by 5 is always going to be 3, the naughty finger, all right? So see how, the mean will always be the same number. It's not really meaningful, all right? So we just don't compute the mean for ordinal data, okay? But we can for interval and ratio. Okay, so let's get back to what we do and how we get it. So the mean divides the sorted distribution into 2 equal parts, okay? So once you've sorted them, you put a line, this is the middle point, and half of the data is below it and half the data is above it, okay? Therefore, you can think of it as the 50th percentile score. That's a concept we haven't run into yet, percentiles. Percentiles, they tend to confuse people when they, who aren't very experienced with them, okay? I want to point out, let me show you that it's a rather simple concept, and so that's often poorly explained and people don't get it. So most of us had to take at some point or more in our lives some kind of standardized tests. Okay, you did them probably in your in primary school. If you took the SAT or the SAT or the ACT to get to enroll in colleges, okay. Many of your universities that you applied to probably required one or both of those tests. Those are standardized tests, okay? And you get your scores back on standardized tests in percentiles. And so people who are only familiar with percentages get these things confused and mixed up. So they find out that they're in the 75th percentile on the mathematics portion of a standardized test. And they mistakenly think, well, I got 75% of the questions right. That's not at all what that means, okay? To be in the 75th percentile means that 75% of the people taking this test scored as high as you did or lower, okay? 75% scored at or below your score. So that means, or in other words, 25% scored above you in mathematics, but 75% scored at your level or lower. Okay, so the median is the middle point. It's the point where 50% of the scores or the data lie below it and 50% lie above it. Okay, that's what the 50th percentile means. Okay, it's the percent of people or scores at or below a certain value. Okay, so the median is the 50th percentile score. Okay. Now, when you have a small number of numbers, which thankfully we'll most often use in this class, to keep things simple, we usually use pretty small, simple sets of data. All right, we're not usually jerking around numbers, variables and data that we have, hundreds and thousands of cases. Okay, so typically we have 5, 10 numbers at the most. So when you have a small number of numbers and you need to, find the median, it's not so challenging usually to do it kind of brute force, okay? You first write them down in a sequence, in order from least to most, and then you can kind of use your fingers, kind of like in the video, take one step and one step only and meet in the middle, and that's the median score, okay? So that's good when you have a short number, okay? when you have numbers only as far as your arms can reach and coming in one at a time from each direction until you get to the middle. Okay? Well, what do you do when you have anything that's, too long for you to use your fingers and your eyeballs in that way? Well, you still must always sort. You or the computer program must always sort the data first. And so here's a little formula that you can use to find the position of the median. I'm going to make this as clear as I can make it, that this is not a formula for computing the median. This is to find the place, the position where the median is, but it does not, there is no formula to compute the median, okay? A computer will use algorithms to do that for us, but we don't have a formula that we plug the numbers in to find the actual median, okay? This is to find the place, the position of the median. So you take the number of numbers and add 1 to that, and then just simply divide it by 2, okay? So the number of numbers plus 1 divided by 2, will find, then you start at either end, the highest value or the lowest value, whatever. Start at one end after you've sorted them and go that number of places, and then you will be pointing to the median, okay? So it's not a formula for calculating the median, okay? We'll see this in just a moment, okay? So the median sounds kind of simple, and it generally usually is. That's the good news. Bad news is it can get a little bit complicated. So there's 3 cases or scenarios that you may run into when calculating, trying to determine what a median is. So case 1 is the best, simplest one, all right? Case 1 is when you have an odd number of numbers, all right? When you have an odd number of numbers, the median is going to be exactly in the middle. You're going to be pointing to one number. Let me give you an example. Here's 1, 2, 3, 4, 5, 6, 7 numbers that I've already sorted, okay? And so we can use our fingers or even our eyeballs and see that, yes, the number right here in the middle, the one number, 6, is the median. Half of the numbers, there's 3 below it and there's 3 above it. So when we have an odd number of numbers, the median's going to be like that tent post or like a teeter-totter fulcrum, okay? It's the point right in the middle, okay? So we love odd numbers of numbers for that reason, because then we're pointing to a single number, boom, there's the median, all right? Let's do it more complicated, okay? Let's use that position formula. So instead of using our fingers, let's see how that position formula at work, all right? There's 7 numbers, odd number of numbers. 7 plus 1 is 8. 8 divided by 2 is 4, okay? 4 is not the median. In fact, 4 is not even a number in here, okay? That's the position of the median. So start at one end. 1, 2, 3, 4. 6 is the median. It works both ways. Start at the upper end. 1, 2, 3, 4. 6 is the median, okay? So fingers and eyeballs or position formulas will find you the median for case 1, okay? Don't forget, you must sort the numbers first, okay? All right, let's move on to, I told you, I'm not going to let you forget this. 4 is the position of the median. It's not the median itself, okay? Do not make that mistake. Let's move on. Case 2. Guess what case 2 is, okay? Case 1 was having an odd number of numbers. Case 2 is having an even number of numbers, all right? So when there's 2 middle numbers, then there's going to be, you're going to be pointing to a place between 2 numbers, all right? So let's add 1 number to that list that we had a moment ago. So now we've got 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8 numbers. And using our eyeballs and our fingers, we can see that, oh, the median is exactly between the 6 and the 7, okay? 4 of the numbers are above that point and 4 of the numbers are below that point, all right? So exactly midway between 6 and 7 is the median, all right? Okay, we haven't yet said what the median is. Let's do it the complicated way. Let's find the position of that median, all right? There's 8 numbers, add 1. So we have 9 divided by 2 equals 4.5. That is not the median. That's the position of the median. So start on one end and count in 4.5. 1, 2, 3, 4.5. Okay, right where my arrow is pointing to the median, midway between 6 and 7. Now you probably don't need to whip out your calculator to figure out what is midway between 6 and 7. Your quick, smart brain has already told you 6.5, 6.5 is exactly midway between 6 and 7. And you're right, the median is 6.5. But let's verify that, okay? So the middlemost score lies halfway between 6 and 7, so the median is going to be the mean of those two numbers. So case 2, when we have an even number of numbers, the median will be the mean of the two innermost numbers. So I said it was midway between 6 and 7. Add those together. 6 plus 7 equals 13. Divided by 2 equals 6.5. Okay? Don't mix up these two formulas. One was just for the position. This is the formula for the mean to calculate the median of those two numbers. 6.5 is the median between 6 and 7. Okay? So 6.5. You wind up having to calculate a little mini mean. All right? When you have an even number of numbers, the median will be a mini mean of the two innermost numbers. Okay? That first example was easy. Let me just show you a more awkward example to see how, oh yeah, sometimes you might not, you got to whip out the calculator, all right? So take these 1, 2, 3, 4, 5, 6 numbers, even number of numbers, okay? 20, 30, 33, 62, 65, 70. All right, I've sorted them. The median is exactly midway between 33 and 62. Quick, what's the number exactly between 33 and 62? Okay, a little harder for most of us to do, all right? So, see how sometimes you got to pull out a piece of scrap paper at least, or a calculator, okay, to calculate the mean of those two numbers. 33 plus 62 is whatever that equals, and divided by 2 equals the kind of semi-awkward number 47.5. The median of this list of numbers is 47.5, exactly midway in between. Half of the numbers are below it, half of the numbers are above it. So, do you see my point? For an even number of numbers, you have to calculate a little mini mean of those two innermost values. I shall call this a mini mean. Okay? So, case 2 is calculating a little mini mean. If you don't know who these are, you gotta pause the video right now and go watch Austin Powers and come back. All right? If you've never seen that movie, stop now and go watch the movie. Maybe not. Save it for spring break. All right. So, case 3. All right, this is where it gets really fun. Buckle your seatbelts, put on your thinking cap, stand up, get a little blood in your brain, get some coffee, and come back for case 3. This one's going to be a fun one. Okay, so case 3 is determining the median when you have an even number of numbers and you have repeating numbers in the middle. All right? Okay, let me say that again. When you have an even number of numbers, like I have here, 2, 3, 4, 4, 4, 5. Okay, there's 1, 2, there's 6 numbers there. All right, so my median is right here between the first two fours. Okay, so 3 numbers are below that point, 4 numbers are above that point. Okay, but we have a repeating value here. So the question becomes, well, what's midway between 4 and 4? Sounds like a silly question, doesn't it? There's a number between 4 and 4. I'm about to demonstrate that for you. Okay? So, now, some people ignore this fact and go with what your intuition just told you, that what's midway between 4 and 4? 4. Okay? Now, when are we typically using the median? Okay, one of them, again, the median is the measure of central tendency of choice when you have ordinal scales. All right, so when you have ordinal scales, you're typically going to lean on the median. Okay, you can't compute the mean. When we have the better data, interval ratio scale data, we typically, we usually use the mean. Okay, and we don't slum down to the median, so we don't worry about this. Okay, so if these were ordinal ranks, okay, and then we wouldn't want a precise number, more precise than 4. I'm going to show you in a moment that there's a number more precise than 4, midway between 4 and 4. Trust me, I'm going to come. You'll see. It's going to be a magic trick. Okay. If we have ordinal data, you can't have your numbers must be whole integers. Okay, your ranks must be whole integers. There's no such rank as 7.13. Okay, so even if I could calculate a median that was precise to 7.13, you can't have a rank of 7.13. All right, if you discover that, oh, I got to put something between 7 and 8, you just have to renumber everything. So this becomes 7, this middle one becomes 8, and 8 now becomes 9. Okay, so when you have ordinal scale data, you can ignore what I'm about to teach you. Okay, but when you have interval or ratio scales, where it's okay to be precise, where you have a possibility for continuous data, where things don't have to be discrete whole units, you can do this. All right, so now this is going to be the second most trivial anal retentive thing I'm going to teach you this semester, okay? You might be wondering, well, gee whiz, what was the first most trivial thing? Maybe it's hard for you to, maybe it's like, wow, weren't there like about 1,000 trivial things this semester? Okay. In my opinion, the most trivial thing I taught you so far was that rounding rule when you had an remainder of exactly 5 and we went rounded up or down to the nearest even, okay? I neglected to say back then that when you run into that situation in class, you should do the right thing and do what use my rule. But in real life, you have to make up your mind. Should I do what Metcalf said was right and confuse the shit out of all these people, or should I do what they're expecting? Everyone's expecting you to round 5 and greater up. Okay, so in real life, you have to decide if you want to do the right thing or if you want to be Batman and confuse everyone, okay? So there's a time and a place for being Batman, and unfortunately, it's not always the right time and place to be as precise as you could be. So, but in my class, you should be Batman, okay? So that was the most trivial thing. On to this second most trivial. Maybe they're tied for most trivial, I don't know. Okay, so anyway, back to my example here. I've already sorted them. So again, the median is right here between the first and the second 4s. Okay, so what's the number between 4 and 4? All right, and I'm going to rush through this. I'm going to rush through explaining this, and then I'm going to walk you through it visually. Okay, so you have to consider that there's upper and lower real limits for numbers. Okay, so the lower real limit of the number 4 is not 4; it's 3.5. Right? Anything from 3.5 to about 4.5. Between those values, you're going to round up and down to 4, okay? So if these were numbers that were rounded, the lower real limit of 4 is 3.5. The upper real limit is 4.5. So do you already get a sense that, oh, there are some numbers between 4 and 4, okay? They go down to as low as 3.5 to as high as 4.5, okay? So the lower real limit of 4 is 3.5. So I use that as my starting point instead of the number 4, okay? Now 1/3 of the 4s, there's 3 4s, so divide them into 3. So they're, each one gets 1/3 of that unit, okay, that they're taking up. They're taking up the 4 place, and each one gets 1/3 of that unit. So if I start at the lower real limit of 3.5, and you see there's 1/3 of the 4, so I have to add 1/3 to that. I'll say that again. There's only 1 4, so if I'm starting at its lower real limit of 3.5 and add 1/3 of the 4s to that. 2/3 are above it, so I'll leave them be. I'm going to add 1/3. So start with the lower real limit, 3.5, and add 1/3, 0.33. There, the median is 3.83. Okay? So, my experience tells me that you're probably confused here. So, let's take a look at this little sketch I've done and see if this makes any more sense. Okay, so let's take the median camping and see if we can see how this makes more sense. Enjoy. Hi everyone. Let me try to explain this crazy case 3 scenario for determining a precise median when you have an even number of numbers and the numbers in the middle are repeating. So our example was we had a 2, a 3, 3 4s, and a 5. All right, now I've already sorted them. That's the first step always in determining the median. Okay, now, simple enough, let's find where the median is. The median is right here between the first and the second 4s, right? 3 of the numbers are below and 3 of the numbers are above. That's the definition of the median, the middlemost point. All right, so the question is, what is a number between 4 and 4? Well, like squeezing water out of a rock or pulling a rabbit out of a hat, I'm here to do a magic trick and show you that there is indeed a number between 4 and 4. So let's give this an example before we continue here. And let's say that we have asked asked 6 people how far a walk they have to get to school. All right. So the first person said they live 2 miles, second person said they live 3 miles, and so on, all right? Now, when you ask people how far away they live, they don't always give you a precise number, okay? So let's put these numbers on a number line and think about what we're talking about, okay? So, when somebody said that they live 2 miles away, what does that really mean, all right? It might mean that they live 2 miles away. On the other hand, it might be as low as 1.5 miles away to maybe as much as 2.5 miles away. So they might live anywhere in that interval. Okay? When somebody says that they live 3 miles away, they could very well mean 3, but it could be anywhere from 2.5 miles to 3.5 miles. When someone says they live 4 miles away, it could very well mean 4, but it could mean 3.5 to 4.5 miles away. And lastly, when somebody lives 5 miles away, that's anywhere between 4.5 and 5.5 miles away. Okay, so there are lower and upper limits to real numbers, okay? So when someone says they live a certain number of miles away, it could mean something quite a bit different. Let me change my story here. Let's mix metaphors here and say these 6 numbers are going to go camping, all right? So I want them each to pitch a tent on this campground here. So there's only 1 2, and so number 2 gets to pitch his tent, taking up the complete zone for the 2s, all right? He gets the whole campground for the 2s, all right? Likewise, there's only 1 3, so she gets to pitch her tent over the whole zone for 3s. Let's come back to the 4s. There's only 1 5, and that lucky number 5 gets to take the whole number 5 campground. So we have 3 campers left, all number 4s, and there's only one, zone here for 4s. So I think the fair and proper thing to do is to give them each 1/3, all right? And try to give them each an equal third. So they're each going to have a smaller tent. So the first number 4 comes in here and takes about 1/3 of the spot. The second number 4 comes in and takes another third, and the last camper takes the remaining third. Okay, so we got 6 tents set up here. Now where is the median again? Okay, these don't line up perfectly here, so my median is pointing right there. Do you see? Now you can already kind of see what the answer is going to be. Am I pointing to 4? The median is not pointing to 4. It's pointing to something a little bit less than 4. So how do I determine the precise value that is? So let's start with the lower real limit. Okay, so that location, if we start there at 3.5 miles, and we have to add 1 tent. There's only 1 tent below the median line, and it's taking up an additional third, approximately 0.33. So add that together, and the median is 3.83. Like squeezing water out of a rock. 3.83 is the magic number partway between the 2 4s. Okay? So, my answer is 3.83 is the median number of miles away that these 6 people live. Voila. So if you have another case like this, perhaps you draw a little number line and take the numbers camping and find out where your median is. So again, I started with the lower real limit for the value and added the number of tenths that I had. I only had 1/10 falling below it, so I only had to add 1/3. If that median had been pointing, if there were 2/10 below it, I would have had to add 2/3. I would have added 0.33 plus another 0.33. Okay? If there were 4 campers, each one would get a 0.25. They would get a quarter of the camp zone. If there were 5 numbers repeating there, they'd each get 1/5, so that would be 0.2, and so on. Okay? So you just start with the lower real limit and add the number of campers that you need. Simple as that. So that's how you squeeze a number out from between a number. I hope now that makes a little bit more sense. Hit me up if that's still confusing, and I'll try maybe I'll try drawing another example for you. Okay. So back to reality now, though. So how necessary is it to do this thing? I told you that this was a trivial thing. So more often than not, we're going to be using the median for ordinal scale. So we wouldn't do all of that precision stuff because you can't have a rank of 3.83. Okay, there's no such, you can't. So there's, if there's a number between 4 and 4, if there's a, if you see there's a number between rank 3 and rank 4, you just have to renumber everything. So this new value becomes number 4, and number 4 becomes 5. You expand it to make room, so you have everything be a whole number. Okay. But you can do this when you have interval ratio scale data. Like the example I used was miles you live from, people live from school. All right, that is a true ratio scale variable, a continuous variable, where it can certainly make sense that somebody lives 3.83 miles away. Of course, you could, you could measure that. You could measure it even more precisely than that if you had reason to or wanted to. Okay, so when you can use it, when you do have an interval scale variable like this, continuous variable, where it does make indeed good sense to be precise, now you know how to be precise. You are Batman. Okay, I have just a couple more things to say about the median, and then thankfully we can move on. So the median, there are 2 desirable characteristics of the median when we do have interval ratio scales. Okay, now again, let me back way up. If you have nominal scale, you got no choice but to use the mode. Okay, that's the only one of these 3 measures that makes any sense. Nominal scale, you use the mode. If you have ordinal scale, you could use the mode, but you can also make the median available, but you can't use the mean. All right, but when you have interval ratio scales, you can use all 3. And as we're going to see, and as you've been using most of your life, you've been using the average, the mean, forever. Okay, that's the most common. That's the one we love the most, the mean. But there's situations when we want to slum down to the median, and here they are. So the things that we like about the median, 2 things. One of them that only one of these really is going to matter to us in this intro level. Okay, so it's said to be insensitive to extreme scores. All right. It's also insensitive to missing scores, and that's not going to matter for us because in an intro class, we're not going to deal with missing data, okay? In real life, you might be missing data, so this is not a trivial matter. So what do you do when you're missing data? When you collect, if you're collecting, if you're doing surveys and, if you're running a study, you might have collected a lot of different variables from a lot of different people, and not everybody gave you everything, or you don't have values for everybody, not everybody took that scale, or not everybody answered that question, okay? Or somebody quit, or didn't show up on this day, or you can very easily be missing scores. Okay, so that's a topic for another day and time, another place. So I want to talk about extreme scores. Okay, so what do I mean by extreme scores? These are sometimes called outliers. Okay, scores that are so far, somebody that's way above and outside of the rest of the group. Okay. So if I ask you to all, if we were all in a classroom and I said, hey, empty your wallets and count up how much money you have on you, okay? Being a bunch of poor, broke college students, I don't imagine I would find anybody to have a whole lot of money. But if I didn't notice that Bill Gates was sitting in the back of the room, okay, open up your wallet, count, okay, 30 minutes later, he's done counting the money that he's carrying, and he's got, $3.5 million on him, okay, all right? If I'm gonna calculate the average income, average amount of money in wallets in the room, Bill Gates is gonna pull that mean way out of recognition, okay, for a bunch of college students, okay? I got 19 people who all have about $3-4 in their wallet, and one guy that's got $3.5 million in his wallet, all right? So when I calculate the mean, it's not going to look like anybody. All right. So let me show you a little more simple example of this. Okay. So here's 1, 2, 3, 4, 5 people. Okay. I asked 5 students to open their wallets and how much in whole dollars, how much do you have on you? Okay. Somebody has $3, somebody has $4, and so on. Okay. So those are the 5 values for the 5 people. All right. Now, trust me on this. I've calculated the mean, add those up, divide by 5. The mean is $6, all right? Lo and behold, so is the median, okay? They're sorted. See, the middlemost case is 6, all right? So both the mean and the median happen to be the same here, nice and tidy, all right? So both of those are good, pretty good, guesses as to what anybody's, has on them, okay? If I had to guess, if I had to bet, how much anybody had without knowing or peeking, my best guess is going to be either the mean or the median, okay? I'm going to be right one time, and I'm not going to be too far off for the rest of them, okay? So both of those are good bets for what the middle, it's a tent post in the middle. It fairly well describes what's going on in this group of 5 people, okay? Well, what if one person's got $100 in their wallet, okay? So change that 10 to 100. Lucky person's got $100 in their wallet, and look, I recalculate the mean, and it pulls it up to $24. Okay, now $24 is correct. That's not wrong, but is that a very good indication of what those 5 people have on them? So for those 4 people, $24 is way more than they have, and for the person with 100, it's way less than they have. So $24 doesn't describe anyone very well in that group. But lo and behold, look what the median is. The 100 value didn't upset or change the median. The median is still plump, sitting there in the middle, 6. Okay? One more extreme example. You probably get it by now, but what if one lucky kid's got $1,000 in their wallet? Okay? One of you has $1,000 in your wallet. Hey, wow, maybe, I don't know, that sounds like a lot of money to me. Okay? I don't walk around with $1,000 in my wallet very often, if ever. Okay? So don't mug me. You ain't going to get much. All right? So, that's going to pull the mean for that group of 5 people all the way up to 204. And 204, these 4 people are like, I wish I had $204. I would be happy to have $204. And $204 also doesn't very well describe this person. It's like, it ain't even close to what they have. Okay? But lo and behold, the median was not pulled out by that value, okay? It's still sitting there at 6. So can you see how when you have extreme scores, when you have outliers like even 100 or certainly 1,000, they pull that mean out beyond recognition with them, okay? So nobody's happy with the mean, all right? It doesn't describe anybody left in the set very well at all. But in this case, the median does a very good job of showing you what's in the middle, okay? So for extreme scores, we like the median. Okay, let me give you some more real-life examples of when we would prefer the median. Income and related things like home values, okay? Those things are usually reported when people want to report an average. They usually report those as medians instead of means because back to Bill Gates, both in income and his home. If you've never heard of his home, he's got this bazillion-dollar home. And so in the neighborhood where he might be living, his home is going to pull the mean value way out of recognition from all of the neighbors, okay? And so, you can't have a home worth less than 0, but there's no upper limit to how much a home can cost. So a really extreme outlier kind of home, like if Bill Gates moves into your neighborhood, I guarantee you he's going to pull the mean home value out of total recognition, and it's going to wind up being a whole lot more than your home is worth, and it's going to be the mean's going to be a whole lot less than what you're going to pull his value down, and so that mean is no longer going to describe the true home value of anybody in the neighborhood, but the median still will. Okay? All right, a good psychology example is reaction times, okay? We use reaction time as an example of a positively skewed number, if you remember, okay? So you can't respond quicker than 0 milliseconds to a task on a keyboard or something, all right? But there's no limit to how, you might be slow, you might be old, you might be asleep, okay? And so most people are going to respond really quickly. This is 0 point, so you hear a tone and you got to press a key, all right? Most people are going to be really quick to respond, okay? Some people are slow, you get old, you get Grandpa Simpson, okay? Pretty much falling asleep, this person's unconscious, this person's in a coma, okay? I'm drawing an invisible skew distribution here, okay? So reaction times are are, these slow pokes, these extreme slow scores would pull the mean reaction time, and the mean wouldn't really describe what most people are doing over here, responding real quick. But the median will stay behind. Okay, so for extreme scores, the median is just that much more desirable. Okay, so we will generally use the median for ordinal data, but we'll slum down with interval ratio scale to the median when we have these kinds of extreme cases or missing data, which I didn't give examples of. Okay, so that's the median, the middlemost score. All right, these were deceptively easy to define. Maybe not deceptively, there's nothing deceptively simple about the mode. It's simple, all right? The most frequent occurring score is the mode. The middlemost score is the median. Quick and handy to define. We saw one example where it was a little bit thick to figure out what the exact median was, but again, it was always the middlemost score once you've sorted them. What's the mean? Here's a good question for you. I challenge you to define the mean. Okay? That's a good challenge question. Define what the mean is, but don't just simply tell me how you calculate. When I ask students to define the mean, they'll quickly say, oh, the mean is when you add up all the numbers and divide by the number of them. Okay, that's not a wrong statement, but that doesn't tell me what the mean is, okay? So the mode was really simple to find. The most frequent occurring score, boom, done. Define the median, the middlemost score once you sorted them, boom, done. Define the mean. The mean is, well, it's, you know what the mean, it's the average. Wrong, all three of these are averages. Crap. See, the mean is a little bit hard to, it's a challenging thing to define, okay? So, I'll come back in just a second and try to define it. Let's first talk about some of the symbols for it. These are reminders. I've talked about this elsewhere. So if you're calculating the mean for a population, we'll use that Greek symbol mu up here, okay? When we are calculating the mean for a sample, we'll use X bar. And here's a perfect example of how I told you that was a pain in the neck, okay? You can see that my bar doesn't line up very well over my X. That's because I had to manually draw it and it got skewed in the display here, okay? So we don't have a symbol for X bar. I had to frickin' manually draw that. So anyway, there it is. X bar is for a sample. And when we're writing APA style papers, again, and only when we're writing APA style papers, we'll just use this nice handy M for mean. And I kind of wish we always used that, but we only use that for when we're writing. Okay, so as you're going to see, as we move on in this course, we are almost always going to be using interval ratio scale data when we calculate things. Okay, so we're going to be very biased, very heavily, heavy propensity towards using interval ratio scale data, and therefore the mean is generally going to be the desired measure, except when we have the extreme scores, when we want to use the median, okay? So it's going to be by far the most commonly used measure. And again, you learned it way back when you were a kid. You called it an average for all of your life until now, but that's okay. So I'm not even going to say this joke in the middle of the screen. You read it yourself. It's not worth it, okay? So here's your first real-life formula under the smiley face, okay? So whether you're calculating, the population mean or the mean for a sample, here's your first real bona fide formula, okay? So sum of x. Add up the scores and divide by the number of the scores, okay? You knew that already. Now you have the formal symbols, there's your first real, tuck that one in your utility belt. Oh, I have a formula in my utility belt now, okay? Congratulations. Oh, you had one a moment ago for the position of the median, but this is your first real good formula. Okay, I've made these points, I hope. We'll use Greek symbols for population parameters, okay? Descriptive statistics for populations are called population parameters, PP. P goes with P, population parameters. And sample statistics, okay? So X bar is a sample statistic, okay? So it's kind of more regular letters for samples, fancy Greek symbols for populations, okay? All right, so we haven't tackled that bigger question of what is the definition of the mean, all right? What does the mean mean? Okay, I'm about to show you some words, and none of them are going to be satisfying. I don't have a, I'll tell you what here, let's look at some of them, okay? Some of these are just factoids, and only one of them is kind of close to a definition of it. So it's the center of gravity, okay? Okay, the second statement is kind of the closest I have up here to defining what it is. It's the score around which there's the least variation. See, that's not very satisfying, is it? The mean is the score around which there is the least variation. Okay? And that's a true statement, but it's not a very satisfying definition of what the mean is. Almost everybody falls on looking up what, when you look up the definition for the mean, they almost always just tell you how to calculate it. Oh, the mean is when you add up the number of scores and divide by the number of them. Okay? And then they might throw in for good measure. And it's the score around which there's the least variation. Okay? The rest of these are just kind of factoids. The sum of the deviations from the mean will always be equal to 0. Okay? Tuck that away in the back of your mind, and we'll see that in the next presentation. Okay? The sum of the deviations from the mean, if you add up all of the deviations, they're gonna always add up to 0, and that kind of verifies that statement. Okay? If the deviations add up to 0 every time, that kind of proves that it's a score around which there's the least variation or the least deviation. Add up the deviations, and some of them are going to be above the mean and some are going to be below the mean. When you add them all together, they wind up being 0 away from the mean. Okay? All right. The mean is most frequently used because this is really dumb too. It's most frequently used because it's most frequently used. It's used in many or most of our other statistics, so therefore we use the mean a lot because we wind up using it a lot. Okay? How's that for a good hand? It's almost like saying, hey, we're going to calculate the mean because I told you so. All right? Here's a good one. The mean tends to be more stable over repeated samples than both the median and the mode are. All right? Okay? That's handy. Let me say that again. It tends to be more stable, in other words, more accurate, more reliable than the median and the mode tend to be. So, if you're doing things repeatedly. Okay? Now, why does that matter to us? Because when we do research, do we want to do it repeatedly? No. We want to do it once, preferably. Okay? Next semester, you might have to take research methods. You'll have to do a research project. How many research projects do you want to do for that course? You want to do it once. Okay? So, when we do samples, we'd like to draw one sample and do it once, and we'd like to know that that was a good sample. Okay? So, if the mean tends to be more stable, then I'm going to want to use that. That's the one I want to use, especially when I'm going to only do things once. Okay? So, we're going to use the mean the rest of the semester. You've been using it since probably you were 10 years old. There it is. Okay? The 3 measures of central tendency: the mean, the median, and the mode. All right? So, I'll take you out with another catchy song. Sorry. See you next time.
Mean, median, and mode. Mean, median, and mode.
How do you find the mean?
Add up the numbers in the data set. Divide the total by the number of items. The answer is the mean or average. Mean, median, and mode.
But how do you find the median?
Arrange the numbers in order from the lowest to the highest values. The middle number is the median for an odd number of items. The average of 2 middle numbers is the median for an even number of items. Mean, median, and mode. Mean, median, and mode.
How do you find the mode?
Just find the number that repeats most often, and that number is the mode. If you find no number that repeats most often, then there is no mode. Mean, median, and mode. Mean, median, and mode. Mean, median, and mode.